So this session is all about ArcGIS Runtime editing your data online and offline. And you'll notice that, hopefully by now you'll have noticed, because you're halfway through the conference, that we've been doing our sessions slightly different this year, in that we've been focusing less on platform and product specific sessions, and there's more generic runtime sessions that are covering the generic capabilities that you can do with ArcGIS Runtime regardless of the platform. So this is another one of those sessions. We did working with maps online and offline yesterday. I see some familiar faces and see some people who came to that session in here, which is good. This is really the next stage of that, is now working with editing online and offline. And hopefully you'll have attended some of the other sessions, kind of generic cross-platform runtime sessions or cross-product runtime sessions that we've been doing at the Dev Summit this year. So what are we going to cover today? We're going to go over an overview of what the editing workflows are at a very high level. We're going to look at the API overview for working with both online and offline editing, because they're essentially the same. So we'll go into the detailed operations and CRUD operations that you need to perform to edit your data, edit attachments, working with templates and working with permissions, things like that. Quite a lot of detail on these, quite a lot of slides. So just, I know it's morning, but you've already had one session, but just, I'll try and keep it as interesting as I possibly can. But what's really cool is that this is probably the first time that we've gone into some of the details of these in a session. So there is a lot of information in here and it is quite detailed, but if you pay attention, you will learn a lot, I promise. So once we've done the kind of details of how to perform the CRUD operations, we'll look at the specifics that you need to be aware of when doing online editing, and then we'll look at the specifics for offline editing, and then we're going to cover editing feature collections or static feature collections that we call, which we support now in version 100, which we hadn't supported before. We'll cover those use cases of why you might want to do that. And then we're also going to talk about map packaging and working with local server and how that workflow is still available to you in Quartz version 100 if you are using local server. So what are the main editing workflows that we allow you to do with version 100 of the runtime? Obviously you have online feature service editing through feature services. We have offline feature service editing and sync, again through feature services using syncable mobile geodatabases. And we'll we covered how you create that offline data yesterday in the offline map session. And today we'll really just be talking about how you edit and sync those. Those are the two workflows that most people are aware of. But there is this third workflow, which is working with static feature collections. ArcGIS Online allows you to create these feature collections, and you can actually bring them down into your application, edit them, and save them back. And they have a completely different performance profile from working with feature services that actually can lead to some benefits. And we can cover those. And then there's still this offline map package editing where you're working with packages created in ArcMap, using local server, using a feature service, spinning up a feature service associated with those feature classes, and then the editing that you perform on those are the same as if you were doing online feature service editing. It's just that you're working against a local service. Just to be clear, right now, mobile map packages, which are where we see the future of offline data workflows created in Pro, those are currently not editable. And we're working on ways of making those editable moving forward. But right now, from a package point of view, the only packages that are editable are the map packages you create in ArcMap and you can use in local server. So feature service-based editing, data access via feature services. These feature services are good for data that changes over time, so you can get the latest edits that other people are making through these feature services. And you can push your edits up. They're good for larger data sets where you don't want to download all of the data in one go, in one big snapshot, because obviously when we're rendering the data in a connected mode, we're just getting the features for that specific extent. We don't have to get all of the features that's in the service. So if you've got a large coverage of data over a large area, but your app's only looking at a small area of it, it's very efficient in terms of pulling those features down. And it scales pretty well. I mean, the server technology, you can scale as much as you like, and it does scale very well, but you have to remember there still are database resources and server resources required to serve those features to your clients. So if you do have a Pokemon Go viral app, then feature services might not be the thing that you want to put in them. You might actually want to use some other methodology, and we'll talk about static feature collections later. Feature service editing is working with simple features only. Simple features are essentially the features that are supported through the WebGIS and the web server model. And that does include attachments. Clients, the general pattern of working with feature services, you apply you make your edits client-side, and then you apply your changes to the server, and it's last in wins. So there's no clever conflict detection. Whoever got that feature in at the last moment, that's the edit that gets maintained on the server, and that keeps it, has some downsides because it's not that advanced, but it keeps it simple and therefore keeps it fast. Static feature collection is quite different. These are feature collections that are created either in ArcGIS Online. Quite a lot of the tools that import data in ArcGIS Online create feature collections. So if you import a shapefile, it generally gets created as a feature collection item. And you can save them in two ways. They either get saved in the map themselves, which essentially the web map JSON has a bunch of feature JSON inside it. And that means that feature collection is just specific to the map. Or you can save the feature collections as its own item, and therefore you can reference that item in multiple maps. So if you're sharing one feature collection across multiple maps and multiple apps, you save it as an item. If you just want it within a single map, you put it right there. These are obviously good for data that don't change that much. They're also good for data that's relatively small, because as we're just getting the static JSON payload for that map, if you put 100,000 features in there, your map document's going to become very large, and it will slow to load, it will be slow to open. However, that has a plus point, right? Because these are completely static feature collections that live on the server as just a file on disk, essentially. There are no server resources involved in serving that out. So if you do have applications that go viral and they have a small amount of data, and the data doesn't change very often, then actually this is quite a good solution for you, because it doesn't rely on any back-end server resources. You can have hundreds of thousands of clients hitting these resources at the same time, and all we need to do is serve that file up over the web, and it works in the app. So feature collections is not something we've really promoted, particularly with Runtime in the past, but there are specific use cases where it makes sense. An example that where a customer used this was for I think it was fires in Southern California a couple of years ago when there was a lot of fires. They published it through their application, through a web application, and it was using feature services. And because it was on the news that day about this is where you go to get information about where the fires currently are, hundreds of thousands of people hit that service and opened that map at the same time. And the server resources, I won't say they ground to a halt, because our server technology is much better than that, but it got slow, let's put it that way. So then they re-architected the map and used a static feature collection, and it just got served out, and they had hundreds of thousands of users opening that map and looking at the features without any slowdown at all. So the performance profiles of these two options are significant, and yeah, for kind of the big viral applications, the static feature collections may be the way to go. So regardless of whether you're using feature collections or feature services, the editing API that you're working with is actually exactly the same. So you work with feature tables. These are the objects in the API that allow you to add, update, and delete features. Also, it's the API that allows you to query features, and that's common across all types of feature tables. In the future, feature tables will be expanded. There'll be a shapefile feature table, there'll be a geopackage feature table. So this base class you'll be able to use across all of your feature table types when it comes to editing and querying. So you'll be able to reuse a lot of your code. Feature tables have features. Features have a reference back to the table that they came from. Features implement the GeoElement interface. GeoElements are things that have geometries and attributes. This is very useful for working with pop-ups, so it doesn't matter whether you've got a graphic, which also implements GeoElement, or whether you've got a feature from a feature table, or whether you've got a KML feature, or working with an identify result from a map image layer. They all implement GeoElement. GeoElement's a really nice generic class that allows you to put things in pop-ups and get hold of attributes and geometries. A feature table has a feature layer. That's how you display the features in a map. You don't have to have a feature layer. You can work with just the database table itself and never display it in a map, and you can edit it and query it. That's why we've got that feature table class there in the first place, is to allow you to work with pure tabular data if you want to. But if you want to show it in a map, bind it to a feature layer, and get and set the renderer, and there's other operations in there to change the visualization of that layer in the map view. When you're working with ArcGIS data, there's an additional class called ArcGIS feature table, and this adds in all the nice ArcGIS secret sauce of things like templates and types and attachments, because an ArcGIS feature table actually gives you an ArcGIS feature, and it's the ArcGIS feature that has the attachments on it. And the ArcGIS feature is also loadable, and we'll cover that a little bit later. There are two concrete types of ArcGIS feature table. One for working with connected data, service feature tables. We're working with feature services, you instantiate that with a URL. There's another one that you work with local data from a geodatabase, and that has a reference to its geodatabase. But the majority of the code you write will be at the ArcGIS feature table level, because it's all the same, and we'll talk about the editing, when it comes to editing, the difference between those two in a second. So in terms of an API, very much overview of what you do, there's two steps to editing data with ArcGIS Runtime, especially ArcGIS data. In general, features are not by reference. So in some of the other, the API overview, we kind of talked about how with version 100 of Runtime, we're really trying to move to by reference semantics for everything, layers and renderers and maps. However, features are an exception to that, because features are a row in a table, and they're actually by value objects. You get a copy of it, you edit it, and when you want to apply the changes, you actually have to call an operation on the table to apply that back. So features themselves are not one of the things that are by reference. They are by value, essentially. So the first thing you do is you get a feature, you change its attributes, and then you call a method to update it on the table. And that's really step one of your editing workflow. And you do that whether it's online or offline. And then the next thing you do is you then apply those changes to the source of that feature table. That's either with a sync-enabled geodatabase, syncing it back to the service, or it's applying those edits back to the service in an online workflow. So depending on whether you're online or offline, this is where the differences come in. The editing, the step one is the same, regardless whether you're online or offline. You can reuse all of that code. But step two is where the differences come in. So we're going to look at, we're going to now go through the operations that you'd need to perform when you're doing step one, which is just the common operations on the data, whether you're online or offline. And we'll go through those first, and then we'll look at the syncing and applying edits later. So in terms of creating new features, the first thing you should do is check that you can create new features. If you think about the user experience of the application you're building, you want to provide a tool for the user to click on to say, I'm going to create a new feature. But you shouldn't show that tool if you can't create a new feature. Some tables are read-only, and you should always go to the feature table and check whether you can add new features before you even show that tool to your user. Otherwise, they're going to click on it and get an annoying error message that says, no, you wanted to do something you can't do it. You shouldn't even present them with that tool. So there's a feature table can add method that just looks for all the permissions in that table to check that it's editable. Once you've done that, and it is editable, you can create a new feature from that table. There's a feature table create new feature method. You can also create new features with a template or a type, and that gives you a prototype feature with all the attributes set up for that specific template or type. But typically, people just create a new feature. It gives you a by value feature object that hasn't yet been applied to the table, but it is set up with all of the right fields and the attributes for you to be able to then go and change them. And the next step is then going and updating those attributes. We try as much as we can to try and catch errors that you're doing client-side when you're editing that feature. So if you have a field that is of type integer and you try and add a string as the value to that feature, we will, as much as we can, we'll try and throw an error as close to where that operation happened as possible. So if you try and do that, most APIs will try and catch that and say, no, you can't add that. That's an integer in a string field, or that's a string in an integer field, and it'll throw an exception there. So we do try and make it easy so that you don't create features that are completely wrong and then get an error much later down in the stack when you can't really do anything about it. We try and give it to you so you can present information to the user so they can actually change things, or you as a developer can change things. But the best thing to do is just check the type of the field before you provide a user experience to allow somebody to do the wrong thing. And then you can build your UI so that it only puts in the right value. So yeah, you've created a new feature, you've updated its attributes, and now you can add it to the table. So it's a multi-step process, and there's a feature table add feature method. It's asynchronous, and it has an error return object, slightly different pattern on every API depending on the language, but essentially it gives you an error. An example would be if you haven't populated a non-nullable field. We'll be able to give you an exception at that point. So there's a certain amount of validation we do when we actually add it to the feature as well that we can't do client-side when you're updating the attributes. So that's how you create new features. In terms of updating existing features, very similar pattern. You get the feature somehow. You check that the feature itself can be updated. So in the previous step, we had, can I add a new feature for you to provide that new feature button. In this case, it's on a per feature basis that you can check whether you can update that feature. And that can update method takes into account table ownership, ownership-based access control, editor tracking, permissions, all of that stuff, so that you can tell whether the user that you're working with actually does have the permissions to update that specific feature instance. And we can take that in control, and then you can check that, and then that allows you to provide another button, which is, right, I want the user to be able to actually edit this feature. And then the pattern's basically the same. You update the attributes, we do some client-side checking, and then you call update feature on the table, and you pass that feature in, and it has the same asynchronous pattern, and it returns a validation error if things haven't worked out right. So some of it very much the same, but the steps at the beginning for whether you're creating a new feature or updating an existing feature are different, and you need to use that can update feature method. Deleting features, pretty similar pattern. You get the feature, there's a different method on the table to determine whether you can delete features. Again, it looks at the capabilities of the service and the table and other things. Again, before you provide that delete button, make sure you, on a table basis, check that you can delete that. That table actually has the ability to delete features. And then you pass in the feature instance to the delete feature method, and it's gone. Same asynchronous pattern, same checking for errors, but at that point, that feature has then been deleted from the table. So that was working with features. You'll have noticed that an ArcGIS feature has a list or a collection of attachments associated with it, and that's how you work with attachments. In terms of how you edit them, similar pattern. You get the feature, however you got it. You check that the table has attachments before you do anything else. There's a method on the feature table, on the ArcGIS feature table, to do that. You can then actually, on the ArcGIS feature instance that you've got, you can call fetch attachments. That gives you the attachment class, which is not a loadable object. The reason we didn't make attachment loadable, you could think about attachment being loadable because you could think about loading the data of the attachment. But however, we didn't want to do that because attachments can be very large. And we actually think you as a developer probably would prefer to have a stream of data of the attachment that you can then either put on disk or send to a UI component, rather than having an object in memory that takes up a huge amount of memory because the attachment itself was a very large binary file. So the attachment class is not loadable, but it does allow you to get the attachment data via an async attachment fetch data method. And you should only get the attachment data when you really need it. So as an example, if you're showing a list of features and a list of all their attachments in a list view in Android, you wouldn't populate the entire list view and get all of the attachments. You'd do it as that list item becomes visible. You'd then asynchronously load the attachment data at that point, so that you're only maintaining a small amount of attachment data in memory at any one point in time. So that's generally how you work with attachments. In terms of editing attachments, again, you should call the method on the feature itself to see whether you can edit the attachments that are associated with that feature. That does checking on ownership-based access control and other things like that. You can then change the attachments on the feature by calling the feature add or update or delete attachment method. And then check that the attachment edits that you've made are okay. You call can update on the table, and then you call update feature on the feature table, and it's applied. So similar to how you edit features in the first place. It's just you work with the attachments of that feature, and then the rest of the steps are essentially the same. So working with attachments is actually pretty straightforward. This is quite different from what it was at 10x. In 10x, we had methods on the table that allowed you to add and update and delete attachments, rather than actually on the feature instance. We put those methods on the feature because we think that's really where you're going to be. You're going to have the feature object in memory, not necessarily a pointer to its table, and it allows you to, hopefully it means that you've got a bit less code to figure out how to edit the attachments associated with the feature. So that's working with attachments. So the other thing that, from an editing point of view, that you should really leverage is feature templates. These are published through the feature service, and you can publish them in a number of different ways. You can either publish them as types, or if you have a unique value renderer on a service that doesn't have types, they get published out as just straight templates. So there's actually two ways that you can get templates for your feature layer, for your feature service. You should check whether there are types there first, because if there are types, there won't be any top-level templates. And if there are no types, then you can go and get the templates. This is a little bit confusing. I don't think we've ever written this up and told people that this is the pattern that they have to do. We've always done it for our template picker tools. So it was actually, when I was writing this, I'd realized that we probably don't have this written down anywhere else. So it's a good slide for us. However, at the same time, what we do want to do is introduce toolkit components that take a lot of this complexity away from you. So in update 2, you'll see a template picker, a toolkit component that will do all this magic under the covers for you, and you won't need to worry about it so much. However, if you're building your own user experience for working with feature templates, then you do need to understand this. So that's how you get hold of what the feature types or feature templates are. Once you've got them, you then want to be able to show, and Justin's going to do a demo of this actually. So you then want to show a swatch of the feature template so that the user can say, yes, I want that one. You do that by, as I say, because this stuff's coming in the toolkit, but you do that by generating a swatch. And the first thing to do is to create a new empty feature based on the template. You can then create a symbol from the renderer using that feature, and then you can create a swatch from the symbol that you then put in your UI template picker. And it allows the users to choose that particular template, and then you can actually go to the table and create a new feature based on that template, and we set up all the default attributes based on the prototypical feature of that particular template type. Again, we'll try and build a toolkit component that does a lot of this for you, but if you're not using our toolkit components or you need to do this now, then you kind of need to understand the workflows of working with these templates. And the best thing to do, because I've talked quite a lot, is to now hand over to Justin to break things up a bit for a demo.
I mean, you basically just did my demo already, Will. I can just switch to the code and you could walk through it and we could be done.
Much better to show it.
Okay. Can we have number 4 to start with? Okay, so we have a simple app here that does some feature editing. And what Will was just talking about is we can bring up a list of all the different feature types we can create from all the different operational layers in our map. So this is the list based off of the types and templates that potentially are on each of those operational layers. And we have our nice little swatch, and we have the name of the feature type. So not a really compelling demo, but it's great, it's useful, it's important, and it shows we have our operational layers that are of different geometry types. So the top ones are one feature class, and then the bottom one's a second feature class of the map, and everything's put together in one list. And then of course from here I could continue on and create a feature of that type and do some editing. But the more interesting part about it is definitely the code. So if we go over to 5. So here we can take a quick look at the code that was sitting behind this. And this kind of walks through exactly what Will was just talking about. So for each of the feature layers in our map, we go through and get the feature table as an ArcGIS feature table. And that's where all the information about types and templates is on. That's the object where you find it. And we do our check to see if there are feature types or if there are feature templates. And then depending on what the operational layer has, what the feature layer actually has, we do something slightly different. We either get our feature types, or so we either get our feature templates and then go through and add each of those templates into our list of templates. Or if it has types, we go through and get the type and get each of the templates from that. Again, all adding it in so we get one list of all the different types that can be created. And then from there, if we want to create our swatches, we can iterate back through our list that we'd created. We make a feature with that type, and then from the feature layer that that's a part of, we create, or we take the renderer and we call symbol for feature. And then from that, on the symbol, we can call create swatch, and we can update that swatch back in our array to show in our table view. All right, back over to Will. And 3.
Good. So that's just a bit of a demo to liven things up a little bit. So now we're going to just quickly talk about permissions, and this is appropriate for both online and offline feature editing when you're working with feature services. And there's a couple of different permissions models that you can configure with your ArcGIS Server feature service. There's editor permissions, which control the ability of what core operations users can do. That's the can add, delete, or can modify features. And you can query those capabilities on the feature table. I gave you an overview of those in each of the steps that you had before, and this just kind of consolidates it all into one place. But the feature table is where you go to find out what the capabilities are. Can I add, delete, update, specific to a feature, or edit the geometry? And then there's editor tracking, which kind of sits on top of that, which is essentially taking care of you, we basically do it for you. So you don't really have to worry about you updating the feature with the user's name. We take care of all that based on the logged in user. But there is a few things that you should probably understand about this. There's some attribute fields. The get editable attribute fields on the table, for example, will not return the editor tracking fields so that you won't accidentally edit them yourself. So hopefully we take care of it, but also leave it in a state that you can't really even mess around with it and break it. And you can get all the layer properties from the ArcGIS feature layer info, which you can get from the table, which give you all the other additional information about editor tracking if you want to. But typically what we see is, as long as it's taken care of you, and as long as you're calling that can update feature method that checks these editor tracking permissions, then you'll be good. So there's editor tracking, which is really, I suppose, less permissions based and more just about making sure we're recording the information about the person that's editing the feature. And then there's ownership-based access control, which sits on top of editor tracking, which actually tells you whether users can edit other people's features. And this is where, if you're the author and the owner of that feature, you can only edit that feature. This is typical for people out in the field collecting data. If they've collected that feature, they can then go and edit it. But if someone else has collected data, they can't edit that person's data, but you're still using the same feature service. So it actually is quite a useful model if you've got people out in the field editing data. Essentially, we take care of it for you again in that can update feature method, and we just check the ownership-based access control rules, and we'll return false if you can't update that feature, and that tells you that to not present the edit feature button for that particular feature. So it's all the same pattern. You don't really have to learn anything new. It's just showing you how it works with ownership-based access control. Those can add, can update, can delete feature methods basically take care of it, all of it for you. In terms of when it comes to editing version data, you obviously can version your database at the back end. All of the edits that happen in the feature service just go into the version that's been configured for that service. When you publish a service, you can configure what version you want those edits to go into. All of the edits go into that single version. You can check whether the layer and the data is versioned if you like, but we don't really think you're going to do much with that, but it is there just in case you need it. And essentially, if you're working with version data, the process is that there should be a back-end reconcile and post process. Once that data goes into that version, then you need to provide back-end processes for you to reconcile those edits with your other versions in that database if you want to for those long transactions. Okay, so that's pretty much an overview of the kind of generic stuff to do with online and offline editing. Now we're going to talk specifically about online editing. The pattern for online editing is such that you can author your data in ArcGIS Online. You can also decide to author your data in desktop and publish it if you're using ArcGIS Enterprise. Features are sent down to the client. Either we request them, or you, if you're in manual cache mode of the feature table, you're requesting those features yourselves, and you're editing them, and then you you edit those features on the client side, and then you apply and push those edits back to the service with the apply edits call. To do this, you use the service feature table. A little bit about the modes of the service feature table. There's the on-interaction cache mode, which is the default mode, which basically means we're caching features as you pan and zoom and query. We call interaction, you can think about as working with that table, whether it's visualizing it in a map or querying it through some query operations. It's pretty good for most data sets. However, if you always want the latest data, then you should call on interaction no cache. You can change the modes of the table, but you need to get hold of the table before that layer and that table has been loaded if you want to change the mode. So you can get hold of that table, change its mode, and then load it, and then we'll load it into that new mode. On interaction no cache doesn't cache anything. Every time you interact with it, it blows it away, and it's good. Queries and operations always go to the server by default. So if you're worried about the latest data, then that's the mode for you. Manual cache mode is completely up to you to define what information you get down client side. And you call populate from service with a query, and then you can call populate from service again and decide whether you augment your existing query or blow the old query array and repopulate it. So it gives you complete control about fetching features. And queries and edits are always done locally. So if you have done a populate from service and then you query that table, it will always be, that query will always work client side and won't take into account any updates on the service. But you can still edit it and you can still apply those edits back to the service if you like. So the online pattern is essentially you edit your features that we had before in the previous slides using add, update, delete, and then you call service feature table apply edits. And this applies all of your feature and attachment edits in one go. In previous versions of the 10.2x, you had to do that in a two-step process. You had to apply your attachment edits first, or your feature edits in one go, and then apply your attachment edits separately. We've bundled all that up into a single call for you. We've kept track of what edits you've made client-side on the table. You call apply edits, and we'll apply them all in the right order and do all the error checking and give you a result that lets you know what features have been applied and if there are any errors. You should try and call that immediately after. The best practice is you edit a feature and you call apply edits. You don't want your client-side cache to get too out of sync and too out of date from the service. It's not an offline mode. You're still in connected mode. So we leave it up to you to do that as soon as you possibly can. However, the nice thing is if when you do call apply edits, you lose your internet connection for whatever, you can wait and then recall that apply edits later, and we'll have cached all your edits client side. They won't have gone anywhere. You can just keep going until you get a successful apply edits call. So it does allow a fair amount of fault tolerance when it comes to network connectivity. The one thing that you do need to know about when in online editing mode is that ArcGIS features are loadable, and they don't always have all of their attribute data. Talked about why that was yesterday. But you should always load the feature before you edit it to make sure you've got all of the latest attribute data and all of the full fidelity geometry data for it. Having loadable features allows us to request for features from the service to make them optimized and not request all fields, and it makes your life a bit easier when it's working with out fields and query parameters. Quick diagram about that. As you can see, it's only the ArcGIS feature object that is loadable. ArcGIS feature inherits from feature, which implements GeoElement. But the top level feature that comes from a feature table is not loadable. So if you're working with the base feature class, you don't need to worry about it. But if you're working with ArcGIS features, you should make sure that they're loaded. Really, the most important thing, just another slide, just to reiterate, make sure you load the feature before you do any editing, just to make sure you've got all the data. And what we're going to do now is switch over to Justin, just to give you a quick demo of online editing and have a look at some of the code around that.
Yep. All right. So we're going to take a look at some of the stuff that Will was just talking about. So here we have one of the samples from the Android SDK, and this is our feature editing sample. So we can zoom in here on one of these particular features, and we can select the feature by tapping on it, and then we can do a small editing operation on that one, and we can change it to a different type. And that information right now is being sent back up to the server, which seems to be taking much longer than it should. And we've updated and attempting to apply. But as Will said, it's okay. All of our changes are still local. They're still here. And if the apply doesn't go through the first time, we can just call it again a second time, and our changes will eventually make their way back up to the server. But
yeah,
that's why I like showing offline stuff better.
That's assuming you've built your app with the expectation that it does fail and that you can then call it again.
Well, of course I did. That's exactly what I did. Yeah, no. All right, so if we quickly switch over. So this, as I said, this is one of the samples that comes with the SDK today. So you can go to the developer site, go to GitHub, and you can actually grab this code right now and reference it. So what we did when we were doing the update of the attributes, we first got our selected feature that we had, and we called load async on it. Once the load was finished, we were able to start editing the attributes on that. So here, this is where we updated the damage type from that house. From there, we first have to update the feature back onto the feature table. So we called update feature, passing in our new feature, because as Will said, they're by value, so we need to give it that feature back. There wasn't the attributes, that was done by reference, but the feature still needs to be pushed back onto the table. So that's where we do it here. And then our call to apply edits to actually push all the changes from the table back up to the server. And that could be called again because it's still working over here too. Must be the internet connection, that's definitely. But so very simply, being able to easily update all of your attributes or geometries after a load is called on that feature, save them locally, and then push them up to the server. Back to Will for some more slides.
Just a quick overview of some of the challenges related to online editing. You can have performance issues if you're working with geometries that are extremely large. We find the coastline of Alaska seems to be quite a large data set if it's relatively accurate, and that sometimes can give you some memory problems. So you do need to think about the features that you're editing. Obviously, it only works when it's connected, yeah, service feature table does allow you to kind of get around of some of these connectivity issues, but you can't get over the fact that you're going to need a connection and a solid connection at some point to push it back to the service. So that was online editing. Now let's have a look a little bit about offline editing. The pattern is pretty much the same. You author your map. You can either author it in ArcGIS Online or you can author it in desktop and publish it through to ArcGIS Enterprise or ArcGIS Online. You can then download the data client side, you edit the data, and instead of the apply edits call being the thing that puts it back up to the server, there's a different call. There's a task called the geodatabase sync task, which allows you to synchronize the data. And that's a two-way sync. So when you call that, you actually push the edits up, and you also get the latest edits down that other people have edited on the server. There's kind of two approaches to working with offline data. We talked a bit about these yesterday in the maps session. But there's the on-demand workflow, which is you take off the features as you need, client-side, based on a specific extent. And there's the more complex workflow of pre-planning your areas and pre-creating some of these packages and geodatabases to be able to provision them out, which allows the server to have a little bit of less burden put upon it. But the sync framework we provided essentially supports both of these, but the pre-planned workflow requires a lot more work on your behalf. The general offline pattern, the thing that you do client-side is you check whether you've got edits. A little bit different from the online workflow where you're in charge of, because you call apply edits every time you edit a feature, you kind of already know when there's a feature edit pending, you built the application to do the editing, so you can call apply edit straight away. With offline editing, there's a bit of a delay between, your user might have been working on that application over 2 or 3 days without any connectivity, so you don't know when he's going to call sync. You want to probably provide an indicator to say how many pending edits there are, or whether there are edits, for him to be able to sync. And you do that through the geodatabase has local edits property that tells you at a very high level whether there are edits client-side that sync. So if you want to provide a very simple red dot that says, yes, you've got edits, you can use that method. If you want more details and to understand how many features have been edited, there's the ArcGIS feature table get added, get updated, and get deleted feature methods that actually give you back the number of features that have been changed in the table. There is, on the geodatabase, also a time-based feature. So you can say, have I had loads of edits since a particular amount of time, to allow you to build user experiences around that. So the first thing you do is determine whether there are edits, and if there are edits, provide a button or automatically call sync, and we'll talk about sync in a little bit. In fact, we'll talk about sync right now. So the synchronization framework that we have, we kind of talked yesterday was more about getting the data offline, but this is purely from a sync point of view. You can do sync in 2 ways. There's per layer sync, so you can call synchronize on a per layer basis, or you can call synchronize on a per geodatabase basis. And actually, when you're working with version data, the data always comes over as a per geodatabase sync. So you can't, that's the only reason why you might want to know whether your data is versioned or not. But you have the option to sync individual layers or sync the entire geodatabase. You have control over the direction. When you sync, you can just ask to download changes that have happened on the server. You can just upload your edits and not get any downloads, or you can do the bidirectional, which is the more typical workflow, which is I want to send my edits up and also retrieve edits down. But there are workflows for upload only. For example, let's say you're just tracking someone's location and you want them to check in and provide the status of their location. They don't care about the location of everybody else that's being tracked, and you don't want them to give that information. You just want them to upload their data. So there are workflows and use cases for all of these options. The geodatabase sync task is what encapsulates all of this, and there's a synchronized method on that. It's pretty straightforward. It's async, and it follows our typical task pattern. I'm going to not do this slide because we're running a little bit short on time. This is how sync works. You don't really need to know it, but I know you want to know it, but you don't need to know it. So what I'm going to do now is, in the interest of time, hand over to Justin to show you how that synchronized concept works.
All right, so we'll start with a quick demo on taking some features offline, doing a generate geodatabase, and then syncing them back up. So this is now switching over to the sample that's included with the SDK on the iOS platform. So this is our offline and edit sync sample. So we can zoom in here, and we can click generate geodatabase. We choose the extent that we want to take offline, and we can also make choice about what layers we'd like to take as well. Right now, we'll just take off the points layer. Hopefully this will work better than the last time I tried to use the server. So this is going to go through now, make the request to generate geodatabase, and once it's completed, it's hopefully going to download it. And there we go. So now we have our features local on the device for the area that we chose, and we can do things like edit some of them. So let's just go here and make a quick edit to say rotation. We can update our feature. We can see we have a little bar at the top that shows we have some edit counts, and our sync button is now enabled. So we can click on sync, and that'll push our changes back up to the server. Switching over to the code. So we first started with our call to generate the geodatabase. And as Will says, both generate and sync follow our typical task pattern. So we set up a generate geodatabase parameters object, passing in some information about the extent that we wanted to take offline, and our layer options. This allowed us to say we didn't want to take off all of the layers from this particular feature service. We just wanted to take that one points layer offline. And then there's other options around what direction the sync is going to be in, and if we wanted to get attachments as well with that. Set up our path where the geodatabase is going to be stored locally, and then get our generate geodatabase job. And from there, we can start the process of actually making the request to the server to generate the geodatabase. Once we had our data locally, we can, for updating after we made our edits, we can take advantage of things like the added feature count, updated feature count, deleted feature count, which is what we use to drive that piece of UI, and to enable when our sync button is active.
Just quickly on the count, just for information, it doesn't include changes to attachments. So that's one thing that we haven't got there right now. So if you have edited a feature that all you did was change the attachment, it won't show up as an updated feature, just FYI.
And then the final thing we did is we synchronized our changes back up to the server. Again, another familiar pattern. Generated our geodatabase parameters option, setting our sync layer options on that and tell what layers we actually wanted to sync, and then created our job and started the job.
That's not what I was expecting. There we go. So that's online editing through feature services, offline editing through feature services and geodatabase sync task. Now just going to quickly talk about static feature collection editing with feature collections. So typically feature collections are created through importing data into ArcGIS Online. Essentially when you open the map, we download that collection. Either it's inside the map or it's a separate item. You can edit that collection client-side. I'll show you the object model for that in a minute, but it's basically another type of feature table, so you can edit it like you do any other feature table. And then to persist those edits, it's slightly different. You either save the map, if it's a map-based item, and we'll automatically persist that into the map, or if it's an item, you actually, as a developer, have to go and save that item back to the portal. So you have a little bit more work to do if you're editing an item-based feature collection. The pattern, the overview of the pattern is you open a map with a feature collection, you create a feature collection layer, or you create a feature collection layer from a portal item, or you can just create a new feature collection layer yourself, client side. You edit the features in the feature collection tables that are associated with the feature collection layer, and then, as I say, you save the map or you save it as a portal item. The object model for feature collections is this. So there's a feature collection layer actually contains multiple feature layers. So the representation of a feature collection, it can have points, lines, polygons, and text in it. Typically map notes, for example. If you create a map notes layer in ArcGIS Online, that actually creates a feature collection for you under the covers. So there's actually 4 feature layers inside that feature collection layer, and we give you access to those. A feature collection layer has multiple feature layers inside it. Feature collection layer has a feature collection object, which actually allows you to iterate over just purely the tables, which are the things you want to edit themselves. And feature collection table extends feature table. So it's not an ArcGIS feature table because it doesn't have attachments, it doesn't have templates, it doesn't have types. So it extends from feature table. So when you're editing that, essentially you're using the feature table API to add, update, delete. You can't add attachments, but you can add symbol overrides. So typically feature layers and feature tables have a renderer that defines the symbology, and you don't define the symbology on a per feature level. However, features that come out of a feature collection table do actually have symbol overrides, and you can set a specific symbol on a specific feature. And that overrides anything you've set in the renderer. So they have a renderer as well, but then you can also override the feature symbol in there. So that's really working with feature collection layers. And now I'm going to hand to Euan to talk about the last workflow, which is working with map packages through local server and desktop.
All right. Thanks, Will. This doesn't take very long. So it is a common workflow to go from desktop straight out to your sort of disconnected environment and then bring the data back into desktop. And today we can do that using tools inside of ArcMap. And so the process is you author your map, you then package up that map and data into a map package, and then you sideload or you provision that map package onto your machine that you have out in the field. And the restriction with this workflow is it's desktop to desktop, or desktop to laptop, or desktop to ruggedized PC. It's not an option for going to Android or iOS, because it's using the map package as the transport mechanism. And once it's on the machine that you're taking out into the field, you can spin up the local server. The local server it's a self-contained sort of HTTP server that runs locally within the machine that only the runtime clients can connect to. It's not a general web server. It has a dedicated connection. But this allows us to actually take the content of the mobile map package, which is file geodatabases, etc., and expose the content as a feature service. And because we expose the content as a feature service, the APIs that Will and Justin have been showing you earlier on this morning, they work exactly the same way. And you can edit your data which is stored inside of, you've got two options, the file geodatabase, or you can have, if you've got a direct connection back to your SDE server, you can use SDE Direct Connect to go back to your original features. And once you're done with editing, you then have to take that file geodatabase back to your desktop, and then you need to write some ArcObjects code to take the contents of the file geodatabase and perhaps merge it back into the source data tables that it came from. So there's a little bit of work to do on the back end to do the merging, but it is definitely possible as a solution. So the desktop workflows publish the data using the local, spin up the service using the local server, and then the actual development patterns, once it's spun up as a service, they're exactly the same as you saw demonstrated today. You make your edits, and then you apply these edits to the tables which are being serviced by the local server, and then you can take these edits and merge them back in. So I think we've got a really quick demo with Justin.
Yep, we do have a really quick demo. So we're going to switch over now. We're going to take a look at our sample application for the Java SDK running on Windows. And inside that, we have a number of samples here, but specifically we have 3 on how to take advantage of using local server. And the one that we'll look at today is the local server with feature layers that Euan was just talking about. So as we start up the sample, we can see that we have a spinner here while local server is actually being spun up for the first time. We create our feature service, and then we add it to our map, just like we would any other operational layer. So if we switch over and take a quick look at the code, we can find here where we made our call to starting local server. And once that's completed, we're able to start to spin up our feature service. So we use a mobile map package, as Euan said, a map package that was published from ArcGIS desktop. We create a local service, and then we start up that service. And once that service is started, we treat it just like any other feature service that we use inside of the API. So we can create a service feature table from it. We can then take that feature table and we can add it to, create a layer and add it to our map. Editing operations, all the rest of the stuff follows the exact same patterns that we've seen throughout the presentation this morning.
Okay, so local server works on Linux and Windows desktops. Can we go back to the slides? All right. Let's just talk a little bit about licensing. With editing, licensing starts to come in at the basic license level. So the new licensing model for Runtime at version 100, we have 4 levels: Light, Basic, Standard, and Advanced. Light is all about read-only access to content in your map. Basic is where editing starts, with the exception of local server. Local server comes in at the standard level because you get access to feature services from map packages, but you'd also get access to a lot of advanced geoprocessing tools. They all come in at standard. We have an advanced level which adds more capabilities, more tools, and the ability to work with more advanced data types. and then there's various extensions. So for the apps that you're building for your mobile devices that make use of the online services or the sync approach or the feature collection editing, it's a basic license or a level 2 named user. If you're using the local server, it's a standard license. Here's a summary here. If you're online, you need ArcGIS Runtime Basic. If you're taking online services offline, you need a Runtime Basic. If you're making use of the local server, you need a Runtime Standard. And that completes the presentation. We've got 5 minutes for questions. Any questions? Question down here?
So for the last option you were showing with the Mac package, do you have to write the push and pull yourself?
The question is, for the last option that we showed with the map package created in ArcMap, do we have to write the push and pull ourselves? The creation of the data, there's tools inside of ArcMap to do that, create map package. But for the actual taking the changes and pushing them back into their source, that's ArcObjects code that you have to write.
With the kind of follow-up, when you're talking about the future of being able to do the project, are you thinking it will be a similar kind of workflow with the local server? The code you right now is going to kind of...
Right, so the question is, what about into the future? Will said at the start that mobile map packages that you can create with ArcGIS Pro are currently read-only. Is the approach going to be similar with local server for Pro packages? No, it will not be. So we'll support the editing of mobile map packages by all of our clients on all devices, and we'll actually, as well as supporting the editing on the client, we'll actually have a set of built-in tools to Pro to merge the changes back from where they came. So it'll actually be a much smoother workflow moving forward. But that's not a workflow that you'll see in 2017. That'll be next year's workflow. Question?
I didn't hear anything about editing version. Geodatabases, is there a supported workflow for that yet?
Yeah. I did have one slide on it.
Okay.
It was very brief, so I glossed over it a little bit quickly. But yeah, so you can edit if you've published a feature service based on a versioned geodatabase, you can edit it. It always edits. All the edits go back to the version that it's been published with. You can't, as a developer, push edits back to a specific version, right at the moment. It just gets pushed back into the version that the service was published with. And then you have a back-end reconcile and post process to deal with it after that.
Right, and then the edits as they come into that sort of associated version, it's the feature service sort of conflict mode of last in wins. So as all the edits come into the name, that specific version, and if there's no such thing as a conflict because the edits just overwrite each other, but then you would have your conflict detection post process to go from that specific version to your production database. And that's where you could handle potential conflicts.
And that works online and offline, just to confirm. You can do sync offline databases that are connected to a version geodatabase as well as
So you could simulate switching by just having multiple published of different versions?
You can simulate switching by having multiple versions associated with different clients. However, there's a scaling issue. You can't scale that type of solution to sort of 30, 40, 50, 100 clients because you've now got 100 versions on your server that you're dealing with. So you've got to think careful about scalability. But if it's to service just maybe 5 or 6 editors out in the field, then that would be an okay workflow. But you've got to think really hard about the scalability. Question? Yeah.
If you've got an app that's going to be 80% of the time online, do you see a pattern of always just supporting offline editing or switching modes within the app,
Yeah, we touched on that a little bit yesterday in the offline map session. That's the awkward scenario that's a bit more difficult to deal with. I think you have to make a decision. If you want to play safe, then I'd go with the offline scenario and just sync it whenever you do have connectivity. That gives you great performance as well, and you can guarantee that you're always going to have the data there. It depends on what type of data it is that the users need to access. If it's kind of critical data that they need, like, you know, public, let's say first responders, you want to make sure they always have the data and go for an offline workflow. If the data's a little bit less important, then maybe you can go with a connected workflow and just rely on caches, on client-side caches. But yeah, you have to make that decision when you're building an app, and it's you have to think about it quite critically.
Yeah, thinking about your map design and the layers within it is very important. There might be actually only one layer in the map or two layers that you're actually editing, but you've got a lot of other data that you need for context. If that data doesn't change very often, you could sideload that data on from a mobile map package, and it's just sitting there, and all you're doing is downloading and uploading the very small amount of sort of operational data that you need. So you can take a hybrid approach as well to try and improve the performance. There's a question at the back here.
The second offline scenario, the feature collection scenario, when you save back to the map, where does the data get saved in an offline scenario?
So, in an offline scenario. Okay, so I think the question is where the data gets saved with the feature collection workflow, correct? There's two ways. It can either get saved in the map as a feature set, JSON representation that actually gets saved in the map itself. So the web map, if you look at the web map spec that's published, it actually has a feature collection definition, and the data actually gets saved in the map. So the more features you add, the bigger the map gets. But you can also reference a feature collection as an item, which means it can be shared between multiple maps, and then that gets saved back as a portal item. And you as a developer are responsible for saving that back as a portal item. So does that answer the question?
Yeah. Question here?
Regarding permission, offline editing, is there any way to collect our permission from an internal permission service, or do we have to get the permissions from the database and so on?
So the question is about permissions, and can you get permissions, or would you be able to receive permissions from an external source? You'd have to write that application logic yourself. Sure, it's possible. But right now, the things that we support for you are all based on the feature service capabilities and the feature service permissions model that you can set up, which is the operations that you support, editor tracking, and then ownership-based access control, and that's it.
Yep.
There is a REST API to manage this?
You can implement custom permissions using a server-side extension, using something like a server object interceptor. And you can actually layer that in, so as requests come in for particular features, you can check your external system and decide whether that user has the appropriate permissions to do the operation. So that's a SOI to do that.
Yeah, but with the addition of kind of scenarios, you show us that we have capability that we need methods. And so means on the parent side,
you would have, yes. So if you want to have a client-side user experience, you would have to implement these permissions, you would have to write that yourself. Yep. Okay, we're just past half past.
We
so we should probably stop. But if you've got other questions, please come to the front. Thank you very much.